In this case, this is case number 2, force and displacement are not in the same direction. Do you guys agree to this?
Yes, sir.
Okay, so what will be work done here then? Our smart boys will answer Vomsai, Bhumi. Yes, sure.
So is it F into S into the, I think, sine of the angle theta?
Okay, I will teach you that. You are almost in the right direction. Please pay attention, guys, all of you. Okay, here what you will do, you will say, boss, I am applying a force. And force and displacement are not in the same direction, they are having theta. Okay, you know about resolution of forces, right? If I have a force here, do you know that you can resolve it along the horizontal and vertical directions? Do you know about that or not? Not really?
No, sir.
No, sir.
Okay. Okay. Don't worry, I'll tell you. Okay, guys, if you can see, I have taken two axes here, x-axis, y-axis. Okay, and I'm saying, boss, this is my force. That means that some box is there, some ball is there, and I am taking a rope, I am tying it, and I'm pulling it in this direction. Which direction? Don't worry. It is something from here. It is along, this is some 4, this is 2. Along 4, 2. Means some direction, no? Some theta. If I say it is moving along 4, 2 means you can find out theta. What is the theta? Was this is going to be, this is going to be y2, this is going to be x4, this is theta. Theta is equal to tan inverse of 2 by 4 or tan inverse of half. That means if I just specify some x, y, z along which I am pulling, you can automatically calculate this angle. Confirm to me you have understood this.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fair enough. Then what I'm saying is, because you are applying this force, here I am doing calculations in physics, lot of calculations I have to do. Okay, and it is simple if I break this force down into along x-axis, along y-axis, along z-axis. Then only it becomes easy for me to work. Okay, so what do you mean by breaking it down? Breaking it down means, okay, you think someone is here like this and they are pulling this rope in this direction. Okay, then you say, boss, can I forget this guy for a minute? Okay, and substitute two people. I want to substitute two people who are pulling in this direction. From here, they are holding the rope and pulling it. Okay, that means you are going to have one force along x-axis. Okay, and you are also going to have one force along y-axis. I am going to draw that. So that you can see it easily. Able to follow what I said? So I'm saying, boss, I don't want you. I want to remove you. And I want to substitute two people. One person is this one. He is going to apply Fx. And there is another person who is here. Okay. He is going to pull here. He is going to pull along Fy. Okay. But it is the body will move such that it is under the influence of this. That means this person is the original person. Okay, he has been replaced by Fx and Fy, two people who are pulling from x-axis and who are pulling from y-axis, such that the overall effect is as if F is being, this guy is pulling F. Are you able to understand this?
Yes, sir.
Then my comment, a question to you is, what do you think about the magnitude of F, Fx and Fy? Magnitude means which will be big, which will be small types.
Fy should be greater, no, sir?
That we cannot comment, but you can comment about F and Fx. If supposing F is 10 Newton, what will be Fx? Will it be greater than 10 or less than 10? Huh?
So it will be less than 10?
Less than 10
Yes,
because
sir, will less than.
see, overall this and this put together is going to be your F. It is, this guy is being replaced by these two people. Okay, so Fx and Fy together will be less than 10. Okay, Fx will be individually less than 10 Newton. Fy also will be individually less than 10 Newton. I don't know between them. It all depends on this angle though for that. Okay, but I can tell that these guys should not pull more than F. Okay, then how will they correlate to F? You will say Fx square plus Fy square under root is equal to F. It's nothing but Pythagoras theorem basically. So if you see, hold on. So this guy, okay, and this are same. This guy and this will be same. In terms of, if I model this in terms of trigonometry as a triangle, so then this is like the hypotenuse, the original force. This Fy will be the perpendicular and this Fx will be the adjacent side, right? Then we can use the Pythagoras theorem. Here we are modeling this lengths based on the magnitude of force. So basically this magnitude, this length will be corresponding to 10 units. 10 centimeters or 5 centimeters, whatever, but it is going to represent 10 Newton, right? You can, that is the beauty of modeling using trigonometry. You can model force, you can model various physical entities. Okay, it's not merely lengths. Okay, so this is 10. Then the relationship using Pythagoras theorem, which you can establish is boss adjacent square plus opposite square should be equal to hypotenuse square. And from that, we can say square root of fx square plus fy square is equal to f. Do you guys agree to this?
Yes, sir.
Okay, so this is what is called resolution. What do you mean by resolution? Resolution is a mathematical process. Resolution, here I am doing of a force. Any vector I can resolve like this. Okay, what do you mean by resolution? Resolution means I am breaking up or substituting. Breaking up or substituting the original vector. Okay, in our case original vector means f. Okay, by two, okay, perpendicular forces or vectors. Okay, in our case we have fx and fy. These are the two mutually perpendicular what you call forces, vectors. Okay, why are we doing it? To make calculations easy. We are going to do a lot of calculations here. For now it is just force. Okay, tomorrow I will say, hey, this is the object here, one guy is pulling like this, another guy is pulling like this, third guy is pulling like this, fourth guy is pulling like this. This is F1, F2, F3, F4. Find the direction in which the object will move and what is the total work done. Then you will get mad and everywhere you're giving the angle. This is at 15 degrees, this is at 120 degrees, blah, blah, blah. All angles have been specified. Okay. Then this kind of a problem can be simplified, can be made easy if I break up this force now into this force along x-axis and I will draw x-axis and y-axis. This force along y-axis, I have these two, fx and fy, f1x and fy, f1y. Then I forget about this guy, I have replaced him. Then I will take this guy. I will also get f4 along x, f4 along y. I will calculate. Then forget this guy. Then I will take f3, f3 along x, negative x, f3 along negative y. I will replace this. I'll forget about it. Like that, all the forces I will be taking only on x-axis and y-axis. And then what happens is my calculation and analysis becomes simple. And in order to do that, the method that I am employing is called the resolution of force. Did you guys follow this?
Yes, sir.
Okay. So you understood what you mean by resolution of force. Now the thing is, yeah, how to calculate it? Very easily you said this is fx, this is fy. How do I calculate it? Okay. For this, you must understand when I say fx, fx is nothing but the projection of this force F along x axis. What is fx? Projection of the original force along x axis. Okay, when I say projection, what I mean is, Bhaiya, you draw the x-axis. From the tip of the first vector, force, drop a perpendicular. Okay, I dropped a perpendicular. Where is it touching? It is touching at this point A. Okay, then you measure OA. OA is called the projection of F along X. Are you able to follow, guys?
Yes, sir.
Okay, just 1 minute. I'll clear up the men. Then it becomes easy for you to visualize. Are you able to follow now? It's a little clearer, no? Okay, good. So what I have done, whatever the force is, whatever the vector is, right? So I want it along x-axis. Draw the x-axis from the tip of the vector, end tip. Drop a perpendicular onto the axis along which you want to resolve the force. So you have decided I want to resolve the force along parallel to x-axis. Drop a perpendicular here. Okay, so it is going to intersect the x-axis at a point. Then this OA, this length OA is called the projection of F. F is the original mama here. Projection of F along x-axis, we call that as Fx. Did you guys understand this?
Yes, sir.
Yes, sir.
Likewise, what about vertical along y-axis? Similarly, what you will do, you will draw the y-axis here. Okay, then from the tip of the force, means you want to say this guy along y kitna hai. So you will drop a perpendicular from the tip along the y-axis. Okay, and then this length which is there, no, this length you will call as the projection along y, or you have resolved this along y, you will call Fy. So, because we are dealing with linear measurement, this will be 1, 2, 3, 4, 5. 5 centimeters, you have modeled it as 10 Newton. Like this, you have dropped it. Assume you are getting 1, 2, something 3, 4. That means Fx is equal to 8 Newton. Here, what you are getting 1, let's say 2. That means this is 2 into 2, this is 4 Newton, something like that. Of course, here 64 plus 16 is not matching, but if you do it properly, both these guys, when you square and add, okay, it will be coming to 10. Are you able to follow, guys?
Yes, sir.
Okay, so I will just complete it for FY2. So from here, I am going to drop a perpendicular. I just showed this for using the Pythagoras theorem. Basically, now this f has been resolved into fx and fy. Okay, and once the resolution is over, then I can forget about f because I have taken care of this. Now this guy is not required. Do you guys follow what I did?
Yes, sir.
Yeah, thank you. So what happens is, hey, supposing these two guys pull for 5 minutes. Okay, so the body will move. The body will move in this way. Under the influence of both the forces, the object what they're pulling is going to move. Okay, so if you look at the original guy, if he had pulled this guy, the body would move exactly the same way. So the original movement of the body is going to be mimicked, is not going to be compromised just because these two guys are coming into picture. So everything, the way the body moves, the distance it travels, the displacement or distance it travels. Okay, the velocity, final velocity after some time, final velocity, its acceleration. Okay, nothing of that is different. In fact, it is, nothing has changed. Everything is as if it would have happened under the influence of this guy. Okay, it is only for ease of thinking, for ease of doing, we have replaced it with both. But under the influence of this, whatever the position of the body, whatever be the final velocity of the body after a certain time, whatever the acceleration with which the body is moving, okay, none of this has been changed just because this has been replaced by these two. Okay, so the entire kinematics of the object, of the body, is the same. Nothing, no change has happened just because you've replaced him by these two. These two are still maintaining the sanctity of the original force. Did you understand this, guys?
Yes, sir.
All right. Now comes the last part. So we have understood three things. First is, what do you mean by resolution? What do we mean by resolution of a force along x-axis, y-axis? We are dropping a perpendicular and we are taking the projection. Okay. Why it is done? We have understood. Why it is done is, it is to make our calculations, analysis easy. Then the third part that remains is how to calculate this. Okay. The way to calculate it, we fall back on trigonometry. We say, yeah, this was 10 and you are telling this is fx, you want to find this out, and this angle is given theta. Let us take, for example, 30 degrees. Okay, can you guys who are very intelligent tell me how to calculate OA now?
Cos 30.
Very good. So if you take cos 30, just give me 1 minute. So if I take cos 30 is going to involve the side OA, which is going to represent my force Fx, and the hypotenuse OB, which is going to represent the known force F, 10, isn't it? Then I want OA, which is representing Fx. So I say OA is equal to OB into cos 30. Okay, what is OB? OB is representing F, which is 10 Newton. 10 into cos 30 is nothing but OA. OA is nothing but Fx. Fx is equal to 10 is nothing but F. F into cos 30. Are you guys following?
Yes.
Yes, sir.
Okay.
Yes, sir.
So 10 Fx is nothing but F cos 30. So now we are discussing the third part, how to calculate the horizontal part. Okay. So the way to remember it is, yeah, you want along this axis, find the angle, bro. Whatever is this angle, F multiplied by cos of the angle. Remember it like that. So this is x-axis, this angle is 30. F sweep cos of 30, product of this will be Fx. Okay. Then how will we find this one Fy?
It will be sine of 30. F into sine of 30.
Very good. So you say, hey, if I want Fy is represented by this length AB. So you will say sine 30 involves AB. So AB divided by OB. Therefore, AB is going to be equal to OB into sine 30. What is OB? OB is our original vector F into sine of the angle. And what do you get AB? AB or this one? This is the force, okay, along the y-axis, projection along the y-axis. That is nothing but Fy. Fy is equal to F into sine theta. If I generalize it as theta, the vertical force is going to be, force along y-axis is going to be F into sine theta. Okay. Other way is, hey, what is the angle between this guy and this guy? 60. 60. F into cos 60. F into cos of the angle. Easy way to remember. Instead of which is sine, which is cos, if you forget, calculate the actual angle between the force and the whatever axis you want. Here it is 60, F cos 60. And we all know sine 30 and cos 60 are the same. So value wise, there is no change. Okay. But if you want to know if this angle with respect to x-axis is given, okay, cos F cos theta will be horizontal, F sine theta will be vertical. F sine theta is going to be vertical. Are we good with this, guys?
Yes, sir.
So,
Yes.
did you understand what you mean by resolution of force?
Yes, sir.
Hmm?
Yes.
Yes, sir.
Okay, chalo. Good job.
So we have to copy all this notes now.
You want to take it down? Yes, please take it down. See, I'm preparing you
Okay, sir.
for properly attacking your 11th should you take science. Okay. So, if you have this level of foundation, your 11th is going to be much easier. So, please make a note of this. So this 1, 2, 3, which I've put here, okay, I just try to explain what do we mean by resolution, why we need to resolve the forces, and how much means by doing all this, how to calculate Fx and Fy. And very important point to remember is that by doing this, you are not changing any of the parameters. Okay, either the distance moved, the final velocity, the trajectory, acceleration, none of the kinematics involved with the body under the action of the original force, okay, are in any way changed. Everything remains as it is under the combined influence of Fx and Fy, because Fx and Fy are imaginary things which we have imagined in order to make our calculation simple. Please let me know once you're done making a note. Okay, now we have understood what we mean by resolving a force. Okay, let's come back to work. So, this is our body object, and now we are pulling it in this direction. This is the force. Under the influence of this force, body is moving along this direction. It is moving along x-axis, let us say. And we will say that the force has been applied at an angle theta. Right? If I know that the displacement or how much distance the body traveled under the influence of this force in the x direction, if I know it, okay, let's say it's some 5 meters, 10 meters, whatever, right? What will be the work done now? Assume F is equal to 10.
Force into
Can you please be a little louder, dear?
force into displacement into force into cos theta into displacement.
Very good. Force into cos theta into displacement. Why did you say this?
Along x-axis f cos theta, uh, and then because it's work, I multiplied it with displacement.
Very good. That means what you're telling is, hey, this force is there, which is fine. I can imagine in my mind that this force is broken up into F along X and F along Y, which is the topic which we just now discussed. Then we say, hey, what is this F guy doing, Fy guy doing here? When I break this force into Fy, what is Fy's contribution? Is he contributing at all? Is the object moving up?
No.
No. That means this F guy is a dummy guy. Whatever this Fy is there, is the object is not being lifted. The object is moving with its wheels only on the x-axis, isn't it? That means this Fy is of no use. Okay, the only force that is actually playing a part in doing meaningful work is Fx. Okay, so what I will do, I will say work done is nothing but Fx, okay, Fx into S. Okay, because Fx is the useful force. F along X, this is the useful force. This is what is actually contributing to the displacement. And just now we have seen what is Fx. Fx is nothing but F cos theta. F cos theta multiplied by the displacement. Okay, and you can write it. Cos theta is a ratio, na? Whether like cos theta can be half or 1 by 3 or whatever, root 3 by 2. So you can say this is F into S into cos theta. Okay, so this you will say is F dot S. Okay, when you are dealing with vectors, are force and displacement vectors? Hello?
Yes, sir.
Then please
Force
answer.
and displacement are
Are
vectors.
vectors, no? So you're dealing with vectors and you want to multiply them because all said and done, you don't want to add force and displacement. Adding force and displacement does not serve your purpose here because the work, the physical thing which you want to calculate work, the physical attribute, that is only a product of force and displacement. But it is not a direct multiplication of force and displacement because the force along the y is not useful. You want only the force along the displacement. Okay, so whenever such multiplication is required, okay, whenever a product between two vectors is needed such that we need A along B. Okay, A means force, along B means along displacement. You don't want A perpendicular to B, that doesn't make sense. So when you want A along B, then we use a vector product called dot product. Are you able to understand what I'm saying? So just like this symbol means something to you, multiplication, this symbol means something to you, addition, division, subtraction. This is all arithmetic. Now, this you will use when you are having scalar quantities. Now you are having stuff, guys, which has magnitude as well as direction, and you want to multiply them. Okay, so you are dealing with product. Okay, but that guy, those guys whom you are multiplying happen to be vectors. Okay, so when you want to do a product between two vectors, there are two types you can do. Okay, one is A along B types. Okay, A along B types, for which you will use the dot product. It is called A dot B. You will not say A into B. Okay, you will say A dot B. Okay, and another type of product is called A perpendicular to B. And for this, you will use A cross B. So this is called cross. This is not multiplication sign. When you use vector, vector and put this symbol in between, you call it A cross B. Kindly make a note of this. Pragati, can you please read this statement again?
Whenever a product between two vectors is needed, such that we need A along B, then we use a vector product called dot product.
So A along B multiplied by B. Okay. See, we need A along B to be multiplied with B, isn't it? This is F along displacement, okay, to be multiplied with displacement. So it is basically Fx, sorry, it is basically Fx multiplied by S. Okay, but what is this Fx? This Fx is A along B, F along S. Are you able to understand?
Yes, sir.
Instead of saying A along B, I think I should just say F along S. I'll say F along S, F along S multiplied with S. What is F along S? Fx. That means I'm interested in f of x, fx multiplied by s. So when such entities are required to be computed, okay, then we use what is called the dot product. Please make a note of this. This particular thing is called vector algebra. You are going to do many things with this. We are not going to discuss too much in detail. What I am telling is just introduction. We are only considering the case of multiplication. Please let me know when I can move ahead, okay? And the definition of dot product is going to be F dot S is going to be F multiplied by S multiplied by cos theta. So when I put these two lines, I mean magnitude of F. In our case, this would simply be 10 Newton. Okay, this would simply mean 5 meter, because we are not bothered about the direction here. This jacket symbol, modulus symbol, means magnitude. Magnitude of force. And here we put cos theta. So this is F into cos theta. That means we are taking Fx. That means we are taking force along S and we are multiplying it with S. Okay. So this is the definition of dot product. F dot S. Okay, then we'll say, okay, you told us that in vectors there are two things. One is called dot product, one is called cross product. Where is that cross product going to be used? Okay, then you look at this. Supposing you are having a nut. hmm? This nut, if I look it from this side, is very tightly, this is bolted. This is bolted. Very tightly bolted. Okay, you want to open it, you are not able to do it. What will you do? What will you do is a question that needs to be answered.
Sir, can you repeat the question once again?
That means you're not paying attention. So sad. So I'm saying this is a bolt. Okay, it is very tight, like your car tire bolts. It's very tightly fastened. You want to remove this. You tried doing it with hand. It didn't remove. What will you do?
Sir, spanner.
You use a spanner, yeah.
Very good. So you take this spanner and you fix it like this. Now what will you do?
Turn it in the opposite
Rotate it.
direction.
Yeah. Here you will be applying the force. Correct, now?
Sir,
Yes, sir.
You will apply the force here. And what will happen if you apply the force here?
we'll have to apply more effort to open the nut.
Open, isn't it? Supposing here you are putting, here you are putting, here you are putting. So which will be the easiest?
F3.
F3. This is a common experiential thing. When you open the doors, okay, the farther, supposing this is the door, this is the axis of rotation of the door. Your door is like this, gate. Anytime you want to open the gate, if you try to push the gate here, it is very difficult. You will go here, here you will push. When you're pushing it here, then the gate will open easily. Why? Because you're increasing this distance, isn't it? Fine. This is experiential. We all know it. Okay. So the bolt is going to open based on two parameters. One is the force which I'm going to apply here. Correct now? And what is the second parameter on which the bolt will yield?
The distance
The
between
distance.
the bolt and the force.
Distance between the bolt and the force. Okay, I will say this is parameter number one. The second parameter on which the bolt will yield is going to be this distance. Now, if you look at this distance, right, what will you call this distance? So if I were to, this same thing I'm showing in front view, this is the spanner. Okay, I am applying the force perpendicular to the laptop. Means if I can just draw some figure, you understood? No, I'm poking it. I'm taking my finger, I'm putting my finger here, and I'm pushing it into the laptop. Okay, that is the direction in which I'm applying the force. Are you able to imagine it?
Yes, sir.
Yes,
And
sir.
this is the distance. Okay, so this is the distance r. If you see, this distance is the perpendicular distance between the force and the axis of rotation. Do you guys agree?
Yes, sir.
Yeah.
Yes, sir.
This is the direction of application of force into the laptop. This distance is a perpendicular distance, and this entity. So what are you applying? Means you are not applying merely force. You are applying force at a distance. So the combined entity F into R perpendicular is what we call torque. Okay, so if you say, hey, I want to remove this bolt, then you will not say, I have to apply a force of 10 Newton. That is an incorrect specification. You will say, if I want to loosen this bolt, I need to apply a torque of something 15 Newton meter, because you may apply this more heavy force at this point. Okay, this distance is less, but force is more. But put together, that F into R is going to be greater than or equal to 15. Or you might choose to increase the distance and apply a far lesser force. But the product of that force into this greater distance will again be greater than or equal to 15 Newton meter. So this bolt doesn't care whether you're pushing it here, you're pushing it here, you're pushing it here. The net effect is the torque that you apply should be greater than 15 Newton meter. And when you do that, it yields. Okay. So that is called torque or turning moment. Torque is nothing but turning moment. Are you guys following?
Yes, sir.
All right. So now I want to ask a question. If this F and R are perpendicular to each other, just like F and S were in line with each other for work case. Okay. See, in the case of 1 minute. In the case of work, in the case of torque. Now we are talking about two things, two physical attributes. You have one force, you have one length or displacement. Here also you have force, here you have displacement. You don't call S, you call it R. The nature of work is such that you want F along S. The nature of torque is such that you need F. Complete the sentence.
Perpendicular to
R.
the R. Perpendicular to R.
Beautiful. Perpendicular to R. Okay. So S length force Newton, F force R meter. Right. This is also meter. This is also meter. This is Newton. This is Newton. But these two guys are entirely different. Their definitions are entirely different. This is F along S I want. That means I want Fx and I want to multiply that with S. So I say, yeah, if I want to accommodate the meaning of Fx, then I have to take F cos theta, F into cos theta into S. Okay, and I define this as F dot S. The dot is going to bring in the along, F along S meaning. Whereas here, I need this F perpendicular to R. In order to bring this perpendicularity definition, I define what is called F cross S. Here, this is not into, this is cross. And what is the definition of this? This will be F magnitude into S, or sorry, not S, it should be R. Magnitude of R into, can you guess, sine theta? Because here we are talking about Fy. We want the vertical component of F. I will explain that in a minute. But so this, if this and this were exactly perpendicular to each other, then this theta will become 90. Then you will have simply F into R perpendicular. If theta is equal to 90, you will simply say F into R, and that becomes torque. Just like if the force were being applied parallel to the displacement, you will not bother about fx and all. You will simply say f into s because it is exactly along s. Only when you have this kind of guy, then you have to take it and say fx. Here, what will be fx? You will say theta is equal to 0, bro. Why? The force is actually being applied along S. What is the theta? Angle between S and F is 0. So F into cos 0 is nothing but 1. It is F into S. So whenever you are, when in 10th, when they define W is equal to force into displacement, okay, they will always say along direction of displacement. So here they avoid that cos theta. Why? Because when the moment you put along displacement, you know that the direction of f and s the same, then theta is equal to 0. No need to confuse the children. But the moment f and s are in different directions, this definition will not hold true. You have to use the definition of dot product. You have to say f dot s, f along s into s, which is nothing but fx cos theta, which is nothing but fs into, okay? Like that, when you're talking about the intrinsic torque, when you want the perpendicular distance into picture, okay, you will have f into r perpendicular. But sometimes what happens is you will not apply the force exactly in the perpendicular way. Okay, supposing you are applying the force like this. This is the direction of force. Here, F and R are not perpendicular. Okay, I will explain that in a bit here. Give me 1 minute. Hold on. Sorry, sometimes I may repeat myself too much, but different people understand it at different intervals of time. Some people understand quickly, some people take little time. Okay, so if force is now being applied like this, and it is making an angle with respect to, this is our r. Okay, r is along this x-axis, this direction. It's making an angle theta. Okay, then just like we resolved our earlier force when we were doing the work, we will also resolve this force into two forces. One, which will be, hold on. What shall I call the red one? Any answer is okay. I'll call this guy as Fy. Guys, are you still there with me?
Yes, sir.
Yes, sir.
So tell me, do you think that this is the original force? This is F, okay? And we have split it into Fy and Fx, okay? That means what we have done is we have uh, resolved it into both the components. Okay, now which one is actually doing the work? Is it this guy or this guy?
Fy.
Fy.
Fy, no? Then we say, boss, what is your contribution here? You are along the R. You will say, boss, along R, waste hai yaar. When I want to rotate the bolt here, you are there. I know you are not zero. You are there, some force is there, but this force is of no significance here. Okay, F along X is of no significance as far as turning the bolt is concerned. Only this guy is going to be the hero. Okay, and we know how to get this Fy. This Fy I can get by taking F sine theta. Okay, and therefore we are having a new multiplication product for vectors because this also happens to be a vector. And this multiplication product where the perpendicular component is coming into picture of this force, Fy is coming into picture, we are calling it as the cross product. And this, okay, in fact, in this particular case, this torque will be R cross F. This product is going to be R cross F, which is nothing but R into F into sine theta. Is it okay, guys?
Yes, sir.
Did you all completely understand this? And that is called the cross product. I'm going to call F cross S as modulus of F. Here also I can put this because F is a vector. This is it's just like A cross B here. Torque specifically is different. Okay, here it is F S into sine of the angle between them. Okay, there is one more thing here which is not required for you. We'll explain that later. Okay, instead of F cross S, you can also say A cross B. A cross B is nothing but A modulus of A or magnitude of A into magnitude of B into sine of the angle between them. This will give you the magnitude of the physical entity called torque in our case, if it is R and F, and you have into n cap. Because when we do this cross product, typically cross product will give you an entity which is a vector. Work is a scalar. So here you don't need any direction. Whatever you have here, no, this is simply magnitude. No direction is there. But when you do a cross product, you are getting something. This something happens to be a vector. Torque is a vector. So torque has to have a direction. That direction is specified along. This is called a unit vector. Don't worry too much about it. It's just that if I define this n cap correctly, I know what is the direction of torque. Is it going anti-clockwise, clockwise? Is it going up or down, left or right? All that direction I will come to know when I specify this n cap, which is not required for us in 10th. Guys, did you make a note of this?
Yes, sir.
All right. So what have we discussed so far? We have discussed about What do you mean by work?
Resolution
We have discussed about what do you mean by resolution of force
torque.
into horizontal, vertical, and this we actually used trigonometry and found fx and fy. Okay, then we discussed about, hey, how do I multiply two vectors? Okay, we discussed about how to multiply two vectors, and then we said, boss, you have two methods. Okay, the first method is called dot product, the second method is called cross product. Dot product, I will say A dot B. Cross product, I will say A cross B. Definition of dot product is modulus of A, modulus of B, cos theta. This is modulus of A, modulus of B, sine theta into n cap. Dot product will always result in something which is a scalar, like work. Cross product always will result in something that is a vector, like torque. Is this what we have discussed so far?
Yes, sir.
Yes,
So
sir.
all this is mainly 11th, no, sir?
What, ma?
All this is 11th standard, no, sir?
No, ma. Till here it is 10th.
All this is 10th, sir?
Yeah, because you will be, here I introduced you what you mean by torque.
Yes.
Torque is very much coming in 10th
Yes,
standard,
sir.
but you will not know that torque, you will know torque is a vector. You will use the term clockwise, anti-clockwise moment. Okay, that means you're specifying the direction. Okay, and in when you're doing equilibrium of bodies, you will be applying this cross product turning point, but every time you will be using perpendicular forces. That's why this extra information about cross product is not required. Otherwise, this is required. All other things are required. Even resolution of force is also required for you.
Okay.
Accepting this information, everything else is needed as per me. Is it okay, guys?
Yes, sir.
Okay, this is the summary. Next, what is there? I will refer to your textbook in a bit. First, I am just free flow. Whatever is coming to my mind, I am teaching you, okay? Which is valid and relevant. All right. Next part is called equilibrium of rigid bodies. I think you guys have some topic called center of gravity also, na?
Yes,
Yes.
sir.
Center of gravity and all is kind of very intuitive, right? It is like you take a rod and where does the entire mass of the rod pass through? If supposing you can give me 1 point, please give me 1 point. Okay, and at that point, if I put my finger horizontally, okay, that means the entire mass of the rod is going to pass through that point, and I am giving a reaction force. That means at that point, the body is going to be in equilibrium. Okay, so that particular point uh, along which on which through which the entire mass of the body is concentrated, seemingly concentrated, that point is called the center of gravity. Do you understand this, guys?
Yes, sir.
Yes, sir.
Okay. Another definition of center of gravity is, hey, you think that this rod is there? No, you think there are some marble masses are there, point masses. Okay, or something on the left hand side, something on the right hand side. Okay, then what is this point you have taken? Call this point P, okay, as the center of gravity. The second definition of center of gravity is, hey, this is the mass, no? Take the turning moment. Turning moment means this mass means there is a weight. Weight means force. Are you okay with me so far? M1 into G. Okay. What is this? This is mass M2. What is the force? M2 into G. Weight. Correct, huh? This is M3 into G. All this means I am replacing this rod with some point masses. Each of these masses are different. M1, M2, M3. Like that, this is like M5 or M4, whatever you want. This is M5. What is the weight acting this side? M4 into G, M5 into G. Okay. Then what is center of gravity? Hey boss, center of gravity is a point. If you take moments around that, what do you mean by moment? Moment means force multiplied by distance. Supposing this is R1, this distance R2, this distance R3, like that. Okay. This distance call R4 and this distance you call R5. Okay. These moments, tau, tau, tau. These guys are called, what kind of moment is this? Clockwise or anti-clockwise? These are called
Anti-clockwise.
anti-clockwise moments. Okay. What about these guys? This is time. These guys are called clockwise moments. Okay. What did you do? You are taking the product of the force or the weight, multiplying it with the distance. Okay, with respect to the center of mass, this point P. This is what you're doing. Here, instead of force, you are saying weight M1 into G. Correct or not?
Yes, sir.
Yes, sir.
So here what you're doing, you are adding it up. That means you're doing M1 into G into R1 plus M2 into G into
Sheesh, Negro.
2 plus
I need to stop being on that band. Again, you left like 3 times.
what happened, Pa? You said something.
Nothing's, I don't have a mic by accident. The mic's
Okay,
open.
no problem.
I
M3,
have audio issues, sir.
no problem. M3 into G into R3. That means you're taking the sum of all anti-clockwise moments. This force into distance, na? This is called, three names are there. You can call it torque. You can call it moment of force, turning moment, or simply moment. All these are synonyms. Torque, moment of force, turning moment, moment. Okay, so when you're saying anti-clockwise moments, means sum of all anti-clockwise torques. Okay, and what about these two? These are all sum of all clockwise moments of forces. Okay, so a particular point P around which the sum of all anti-clockwise and clockwise moments are the same, or the algebraic sum of moments, algebraic sum of moments or torques or moment of force. Algebraic should be equal to 0. Algebraic is equal to 0. You can say like this, or you can say sum of all anti-clockwise moment is equal to sum of all clockwise moments. So that particular point P around which all this thing happens is also called the center of gravity. Are you able to understand, guys? And I've explained this for a simple rod, uniform rod. But the same definition holds true even if it is a different shapes. It can be a disc, it can be a whatever shape you want. Okay, this should hold true. This is also a definition of center of gravity. And of course, you have various techniques for finding it out, the plumb line method and all that, which are quite straightforward. You can read it from the book. Guys, shall I remove this?
Just a minute.
Done, sir.
All right, thank you. Okay. Now you understood what you mean by turning moment or this thing. But I was explaining this to you in the context of equilibrium. Okay. See, when someone says I am done, if you guys are still doing, you need to let me know. Equilibrium of rigid body. Rigid body means, hey, I have some scale. Okay. And, I am supporting it at 2 points. I'm adding some weights. And the scale itself has got its own weight. Okay, and the bar is in the same position. It is not moving. Okay, this is called static equilibrium. This is called static equilibrium. Means the rod is acted upon by multiple forces. Okay, this is mass m1 is dangling here, 10 grams, 20 grams. m1 into g is the force which is acting at this point. Weight is acting through this point. At some other place you are dangling some other mass, m2 into g is acting. These are called supports. These are also called knife edges. Knife edge supports means like two fingers. You are putting two fingers and or points around which this entire scale is supported, and weight is also acting through some point, and body is equilibrium. It's in balance. Okay. Then what they will do? They will ask following questions. Find reaction at something. You call this point A. This is point B. Find reaction at A and B. They may say this. Okay. They may ask, find what is the mass required, how much is the mass required to balance this. Means they will give you M2, they will say this is the like a reference end, knife edge is placed at this distance, and weight is passing through center. They'll say another mass is at this distance, another knife edge is at this distance. All the distances are given. Okay, they will say, boss, I am hanging a mass M2. Can you tell me where I should hang mass M1? They may ask this, and they may ask you to find out this distance. Okay, first is how much to balance. Second thing is they will ask where to balance, where to hang. Means they are asking for this dimension x. Okay, so these are very important questions that will come, okay, under this chapter force. This is covered under the topic called static equilibrium. Okay, so the first question you will ask is, hey, I don't know what you mean by reaction. Can we just talk about it? Correct or not? Do you guys know what you mean by reaction?
No, sir.
Sir, is it the clockwise or anti-clockwise movement?
Reaction means, see, Newton's third law, every force has an equal and opposite reaction, isn't it?
Yes, sir.
So when you talk about reaction, you are talking about force pairs. Force pairs, okay? Because Newton said, yeah, if you are having a ball, okay, this ball is colliding on this ball, right? He is saying that this is called ball A, this is called ball B. The force exerted by ball A on ball B, thak karke is you're putting it this side, right? Is equal and opposite to force exerted by ball B on ball A. B on A. Okay, so this will be in minus, means this force will be acting on this direction, this force will be acting on this direction. Are they on the same object? No, they are on different object. Where is this guy acting? This guy is acting on B. Okay, this is FA 10 newtons acting on B, means B is going to move this side. Okay, but at the point of collision, B is also giving a banging on A, this side. What is this called? B on A. Which direction? Towards the left. So this is going to be minus. So both these guys will experience equal and opposite forces. That is what is the Newton's third law. Are you okay with this?
Yes, sir.
Yes, sir.
Other examples, rocket. A rocket is spewing gases from its rear, okay? Then it is, going in this direction. It is applying a thrust on this direction, the gases. That means the rocket is itself is being applied a force on this direction, isn't it? So again, this is equal and opposite. Newton's force pair. Okay, Earth and Moon. Earth is pulling the Moon in this direction. Moon is also exerting a force, gravitational force on Earth in this direction. They are not; these forces are on different objects. Okay, Earth is pulling the Moon means Moon is being pulled by Earth, right? So it is, you can think one guy is standing here and he's tying a thread and pulling the Moon here. So Moon is experiencing the force. Okay, that you can call F1 or F Moon, force on Moon by Earth. Then you think there is a guy on the Moon, he is tying a thread and he is pulling in this direction. Okay, that will be force experienced by Earth because of Moon. Okay, these are the two forces. They will also be equal and opposite in direction. Is it okay?
Yes, sir.
All these are force pairs: collision, rocket, gravitation. You can think like this. Supposing you are in space, okay, and you are like you've seen the Gravity movie, na? Have you seen that Gravity movie? Have you seen the movie Gravity?
I've heard about it. Interstellar is also there.
Interstellar gravity. Okay, so what they do is you have these space stations are there. Okay, inside these space stations you'll be doing a lot of work. I have drawn a space station like a satellite. Okay, so some repair happens means they have to sit on this chair. They will be linked to this. They will perform some repairs, then they will go back. This thing breaks in one of the movies. Okay, and that guy will be he will be drifting in space. What can he do in order to reach his station? Supposing this thread is gone. No one wants to answer. Okay, he came out, no? He has a toolkit with him. What he can do is he can take a heavy spanner and he can chuck it in this direction. So if he takes a heavy spanner and chucks it in that direction, okay, he will also experience a force and he will start moving towards his workstation. Okay, so this also will be a force pair. Do you guys understand this?
Yes,
Yes,
sir.
sir.
Thank you so much. So when you say reaction means this only. Hold on. Something happened. Okay. All right. So force pair means that only. If weight is, if you're having a knife edge, this knife edge is going to give a reaction in this direction. Okay, because its weight is here. Wherever you have a support, okay, the knife edges will offer a reaction in this direction. Weight will be here, knife edge will give like this. Ladder, when you have a ladder resting against a wall, okay, what happens? The wall is going to push in this direction. This is called reaction of the wall on the ladder. Okay, then if a book is on the table, if a book is on the table is going to give a force, normal reaction this side. Okay, the weight will be acting in this direction. Is it okay, guys? So these kind of forces which are offered, these are called reaction forces. This is also called reaction. See here, this is perpendicular to the plane. In fact, this is called normal reaction. This also is called normal reaction. If supposing you lift a heavy book in your hand and you reach your hand outside, okay, you stretch your hand. This is your hand. You are stretching it, and you are keeping a heavy book here. Okay, what happens? Your hand will pain. Na? The muscles of your hand pain, right? Why? Because when the book is pressing here in this direction, you are also applying some normal reaction in this way. Okay, in order to keep that hold the book, you are here basically. This is your hand. So your shoulder, your hands, everything will pain. Okay, if you don't apply that equal and opposite force, your hand will go off like this and the book will fall. To prevent the book from falling, you are applying a force in the opposite direction. Yes or no? Okay, then only the book will be in its place. Do you guys understand this?
Yes, sir.
Okay, I see it is becoming time for you to go, but now that I've explained to you what you mean by reaction, I will just tell you briefly the condition which will cause this rod to be in static equilibrium. One is the sum of all the forces on this rigid bar should be equal to 0. This is point number 1. And point number 2, as you would have guessed, is the sum of all the torques on this bar should be equal to 0. Just make a note of this. This is for static equilibrium. Equilibrium of rigid bodies, static equilibrium. What are the two conditions? Sum of all the forces, or you can say upward forces total should be equal to downward forces. And here you say all clockwise moments should be equal to anti-clockwise moments. You can take the moments about any point. You can take all the moments about A. Okay, you understood now? Or you can take moments about B, or you can take moments about W. Any point you want to fix, you fix. But around that fixed point, the sum of all the torque should be equal to 0. These are the two conditions for static equilibrium. Tomorrow, we will look more in detail around this. Okay, thank you guys for your time. If you have doubts, just reserve
Thank you, sir.
them. We will do it in the class tomorrow. Tomorrow is an important class, please don't miss.
Yes, sir.
Okay,
Okay,
sir.
Thank
Thank
you,
you,
sir.
sir. Bye, sir.
bye.
Thank you, sir. Bye,
Bye,
sir.
sir.
Bye, da. Bye.
Thank you, sir. Bye, sir.
Bye. Bye. Nalini ji,
Yes, sir.
ಪರವಾಗಿಲ್ವಾ?
Yeah,